So if I talk about cyclone, we all know what is cyclone. The movement is what? The movement is like this. It's in a circular manner. You don't have cyclones along equator, right? They'll be somewhere north of equator or the south of equator, but not along the equator. They will originate in the ocean. So let's say this is the coast of India. Here you have the tropical cyclone originating, and once the tropical cyclone originates, they move towards the coastal areas. Hello everyone, welcome to PW OnlyIAS English channel. I'm Dimple Nankani, the faculty for Geography and Environment in the English medium channel. I teach in Titan batches. So we have started off a lot of topics which are important for your prelims examination. We'll continue that topics. The topic of discussion that we have today is cyclone. So if I talk about cyclone, we all know what is cyclone. Cyclone, the word cyclone comes from the word cyclos, which means the coil of a snake. So like we have the coil of the snake, that is in a circular pattern, you also have cyclone in the circular pattern. So what are cyclone? Basically cyclones are low pressure system. They are a rotating system. There is rotation, as you can see, going on. So these are low pressure system, rotating system, localized low pressure system with the wind surrounding converging from all the side. How do they move? They move anti-clockwise. They move anti-clockwise, as you can see, in the northern hemisphere. So you use the word can, that is cyclone that moves. You use the word can, which is cyclone moving anti-clockwise direction in the northern hemisphere. You use the word can. So how do they move? They move anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere. The movement is clockwise in the southern hemisphere. A low pressurized system, a circulatory system with the winds which are converging from all the side, and this is how the movement it is. In case you want to see this, so it's actually a low pressure system which is with a circular isobar. It is surrounded by high pressure system comparatively. We know that the wind would travel from high pressure to low pressure. Wind generally travels from high pressure to low pressure. It should have traveled straight, but because of the Coriolis force, the wind gets deflected, but then it gets pulled towards the low pressure. So it would have traveled straight, but because of the Coriolis force, it gets deflected to the right in the northern hemisphere and then gets pulled away. Again, it would have traveled straight, but because of the Coriolis force, the deflection is to the right, but then it gets pulled away to the low pressure. Again, it would have traveled straight because of the Coriolis force, this deflection to the right, but the low pressure pulls it towards itself. So how is it that in the northern hemisphere, where the Coriolis force is deflecting the wind to the right, the movement is what? The movement is like this. It's in a circular manner, which is anti-clockwise. So cyclone anti-clockwise in the northern hemisphere, and cyclone is clockwise in the southern hemisphere. Cyclone is clockwise in the southern hemisphere. That's what we've said, that it is a low pressurized system, circulatory system, moves anti-clockwise in the northern hemisphere, clockwise in the southern hemisphere. It has a localized low pressure with the winds converging from all the side. Now, a very important point that you should know is that cyclones do not form at the equator. Why? Because, moving on here I said that the cyclone are getting deflected. They are rotating, they are circulating because of what? Because of the Coriolis force. The Coriolis force was responsible for the movement. The Coriolis force was responsible for this movement. What happens at the equator? At the equator, you assume that Coriolis force is 0. At the equator, you assume that the Coriolis force is 0. So wind does not get deflected. Because Coriolis force was responsible for deflection, the wind rather travels straight. Again straight. So what happens? This low pressure gets filled up. Rather than intensifying, the low pressure gets filled up. So cyclones at the equator, we know that the Coriolis force is 0. At the equator, the Coriolis force is 0. Therefore, the low pressure gets filled instead of getting intensified. And that is why you will see that the tropical cyclones are not formed at the equator. They are not formed at the equator. If I show you the map, this is the map of the tropical cyclone, wherein all you have the tropical cyclone on the world map. If you want to look at the places, this is the way you'll have cyclone. You can have cyclone. You will not have cyclones along equator. You don't have cyclones along equator, right? They'll be somewhere north of equator or the south of equator, but not along the equator, because the tropical cyclone, Coriolis force plays an important role, and at equator there is Coriolis force is 0, therefore the tropical cyclone is not formed. So what I am dealing is, I am dealing majorly with tropical cyclone. However, is there only one type of cyclone, tropical cyclone? No. Cyclone basically means a low pressure system. If it is found in the tropics, it is called as tropical cyclone. If the low pressure system is found beyond the tropics in the mid latitude, it is called as temperate cyclones. Not only do the tropical cyclone and temperate cyclone differ by locations, but they also differ by the reason for the genesis of the low pressure. Why is the low pressure formed? What is the reason for the low pressure? Is the reason for low pressure some related to heat, thermal reason? If that is the case, that is tropical cyclone. In the tropical cyclone, the low pressure is formed because of the thermal reason, because of the heat from the ocean. Whereas in the temperate cyclone, the cyclones that are found in the mid latitude, the low pressure is generated because of some other reasons. It is not because of the heat. It is because of the movement of the Rossby waves. It is because of the movement of the air masses, etc. So there are, we said cyclone is nothing but a low pressure system. The low pressure can be because of the thermal reason, thermal origin, that heating and the rising air. This is seen in the tropical latitude, heating of the air and rising of the air. So heat related factors. This is seen in the mid-tropical latitude, therefore this is tropical cyclone. The other reason for the genesis of low pressure can be dynamic. That is related to the movement of the Rossby wave, related to the movement of the air masses. This is found in the temperate latitude, therefore called as temperate cyclone. So here you can see there is air masses, two air masses, which are forming, the movement is forming a low pressure, and this is this is seen where? This is seen in the temperate cyclone. Whereas the rising of the air, the rising of the air currents is responsible for the genesis of the low pressure. This is seen where? This is seen in the tropical cyclone. So tropical cyclone is thermal in nature, whereas the temperate cyclone is dynamic in nature. Moving on here. Moving on to the tropical cyclone, that is the major point of discussion. What are tropical cyclones? These are nothing but violent low pressure system. They are very, very violent. Okay, and they are low pressure system that originates where? That originates in the ocean alone. Very important. That originates in the ocean alone, in the tropical areas. They will originate in the ocean. So let's say this is the coast of India. Here you have the tropical cyclone originating, and once the tropical cyclone originates, they move towards the coastal areas. They start moving. They start moving towards the coastal areas. They start moving towards the coastal areas, and when they move towards the coastal areas, they bring a lot of destruction because of the heavy rainfall and the winds. The winds, the heavy rainfall, when the cyclone moves towards the coast, it causes a lot of destruction. That is it. We know that it is moving anti-clockwise in the northern hemisphere, and it is moving clockwise in the southern hemisphere. It moves anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere. Now let us look in detail somewhat how is tropical cyclone formed. I said tropical cyclone is seen in the tropical latitude. It is seen in the tropical latitude. It is seen in the warm ocean. The warm ocean is responsible for it. So if I talk about this is ocean which is very, very warm. The temperature is about 26 degrees Celsius, warm ocean. The warm air is rising. The warm air is rising. As the warm air rises, we know as the warm air rises, as it rises above, it will go up, and what will happen? It will cool. It will cool. As it rises, it cools down. And when it cools down, what happens? You have clouds. So what is happening? The first stage, there is high humidity. There's a lot of humid condition, water vapor. There and the ocean temperature should be above 26 degree Celsius. What happens? The water evaporates from the ocean surface. Water vapor is evaporating, and what is it forming? It is forming clouds. As this continuously occurs, as this happens on continuous basis, you have a low pressure that starts generating. The low pressure starts generating. So here there's lot of air, warm air rising, and a low pressure is starting to develop. And then we know once a low pressure develops, what will happen? The wind will circulate. The wind will circulate. The wind will circulate in anti-clockwise manner in the northern hemisphere. The wind starts circulating. You have the circulation that starts taking place. So a column of low pressure is found because there is continuous evaporation, and then over the time the whole circulation system starts. The wind starts. So let us understand. So this is the basic process. Warm air rising, low pressure getting formed, and the circulatory movement that is starting. But what are the essential conditions that contributes to the development of the tropical cyclone? One that we've already seen, that you would need a ocean surface with temperature above 27 degree Celsius, right? We also need Coriolis force for the vortex to be formed. We saw that the tropical cyclones are not found in the equator because there is no Coriolis force, and we need Coriolis force for the circulation to start taking place. So you would need ocean temperature above 27 degrees Celsius. You would also need Coriolis force. In case there is a weak low pressure over the ocean, if there is a weak low pressure, suppose on the ocean there is a weak low pressure that is already there, this will facilitate the tropical cyclone more. So a weak low pressure or a low cyclonic circulation, if it already exists on the ocean surface, it helps in development of the cyclone. Okay? Not only do you need, now moving on to the fourth conditions, not only do you need a low pressure surface on the ground, not only do you need a low pressure surface on the ground, you should also, what happens here? The air is rising, the air is rising, the air is rising. This air above should diverge out. Should diverge out. So not only do you need a low pressure system on the surface, you also need divergence at the upper atmosphere, so that the upward movement of the air facilitate the maintenance of this low pressure. This low pressure should be maintained. So what is the fourth condition that you need? The fourth condition that you need is there should be divergence around 9 to 15 kilometer in the above atmosphere, in the upper atmosphere, which sucks the air from the ocean surface above, and there is this upward movement of the air is accelerated and the low pressure is further intensified. For this low pressure to sustain itself, there should be upper air divergence. There should be upper air divergence. Okay? Moreover, one important conditions that you generally hear is the condition of low wind shear. What is wind shear? Wind shear is the difference in the vertical movement of the air column. Suppose the air column is rising here. If it rises here at, let's say, 8 km per hour speed, here it should rise at 9 km per hour. Here it should rise at 9.5 km per hour. The difference in the vertical movement of the air is called as wind shear. What is wind shear? That the difference in the vertical movement of the air. Now, you want to maintain this low pressure below. As you want to maintain this low pressure below, the difference in the vertical movement of the air column should be less. Why should it be less? Because if it is too much of difference in the vertical rising, the low pressure cannot sustain itself. So what do we need? We need low wind shear for the cyclone to be formed. What is low wind shear? That is low difference in the vertical movement of the air. Okay, so wind shear. So we should know that the vertical variations in the vertical wind speed should be minor. That is, this is known as low wind shear. This term wind shear is generally used by the pilots when they are flying the jets, when they are flying the aeroplane. They would say that the wind shear is more, the wind shear is less, because they will that ways they can plan the journey better. Okay, now, so this is about your tropical cyclone. So what we've seen, what is a cyclone? Then we moved on to understand that what are the two types of cyclone. What is cyclone? The term It is basically the coil of a snake. Low pressure system, circulatory system, rotating system, cyclone. What are the two types of cyclone? Tropical cyclone and temperate cyclone. How do they differ from each other? By the location as well as the genesis of the low pressure. Then we moved on to understanding in detail what is a tropical cyclone and what are the conditions for the formation of the tropical cyclone. Right? Tropical cyclone is the cyclone that is found in the tropics. What are the conditions? We've seen there are 5-6 conditions that we have listed here. Moving on. Now, we know that the tropical cyclone, they originate over what? They originate in the tropical oceans. And when do they originate? They originate in the late summers. Okay, that is somewhere in August to November. You will not see tropical cyclone in the month of May, June. It is so hot, but still you will not see tropical cyclone in the month of May and June. You will see tropical cyclone in the late summers, which is August, which is September. October is the main season. Why? Why do you see tropical cyclone in the late summers and not in the early summers? It is because tropical cyclone are formed in the oceans, and ocean water takes time to heat up. Though the summer is intense in May and June, but the water does not warm very fast. The water warms by late August, September. Water takes time to heat up. And once the water will take time to heat up, once the water is heated up, only then you will have water vapor, only then you will have warm winds rising over. Therefore, what are tropical cyclones? They are formed in the tropical oceans, and when they are seen in the late summer, which is in the August to November, and that is they have thermal origin. The heat of the water is providing energy to the cyclone. Because of the Coriolis force, we've seen the even local convectional current, even the local small convectional currents, they will take up what? They will take up a whirling motion. They will take up a circulatory motion. Why? Who is responsible? Coriolis force is responsible. How? We've already seen that. And then we know that once the tropical cyclone is formed, it will not stay on the ocean forever. It will start moving. It will start moving towards the coast under the influence of what? Under the influence of the trade winds. They will move from west to east. They will move from east to west. They will move from east to west under the influence of what? Under the influence of the trade winds. As we know that the trade winds are southeasterly winds and the northeastern winds. So trade winds, they'll push the tropical cyclone towards the land, towards the coast. If the tropical cyclone is, let's say, found on the Arabian Sea, it will also move in this direction. It will also move in this direction. Okay. Why? What is the movement? The movement is influenced by the trade winds, and therefore they are influenced towards the land. So tropical cyclone, the formation condition and the origin. What are the stages? The stages are, firstly there is initial stage, then the cyclone reaches a mature stage where the cyclone develops in a full-fledged manner, and then the cyclone ends. So the journey of the cyclone is the initial stage, the maturity stage, and the end. Like we have, everyone has this stage. So we are looking at the development of the tropical cyclone. The development of the tropical cyclone. The development class can be classified in 3 stages. What are the 3 stages? The first stage is the initial development stage, when the tropical cyclone is developing. What is happening? The water vapor, there's transport of water vapor and heat from the warm ocean. The warm ocean transport water vapor and the heat to the above air through evaporation. This leads to creation of a cyclonic storm. The first stage, there is transport of the water vapor from the warm ocean to the air above. This leads to creation of the cyclonic storm. A small cyclone, a small low pressure starts developing here. Now this air, as it is going up, right? As it is going up, it will condense. We know what happens. The clouds start getting formed. The clouds start getting formed. So as the cyclone is formed, the clouds are there. So it will condense, it will form clouds. What happens in clouds? What is cloud? Basically, when the water vapor is converted, water vapor which is a gas, rises above, it cools down, it converts itself to water droplet. That is cloud. Water, the aggregation of water droplet is cloud. So what is happening? Look at the process. The water vapor is cooling. As it is cooling down, it is converting into water droplet, which is cloud. So it is releasing of energy, it is giving of energy. So here the condensation, that is condensation of the rising air above, this creates to the formation of vertical cumulus clouds, and this condensation releases heat outside. The heat is released outside, and the entire column of the air, is warm. This becomes warm. The entire column of the air starts becoming warm. Okay? So first stage, low pressure is getting formed, the air is rising, the air is warm, it cools, it forms clouds, and it makes the entire column warm again because of the release of the energy. So first, this is the initial stage. The second stage, what happens? A fully developed tropical cyclone is formed. You'll see what is a fully developed tropical cyclone. This is a fully developed tropical cyclone. So in the over the time, you have a fully developed tropical cyclone which has what? It has eye. It has a eye here. It has huge big cloud. You can see this is a huge big cloud which you called as a cumulonimbus cloud, which you see as the cumulonimbus cloud. So what does a fully developed cyclone has? It has eye. This is eye. It has a wall which you called as eye wall. It has a wall which you called as the eye wall. Okay. It has circulatory winds. It has circulatory winds, as you can see. It also has warm air rising. It has warm air rising. It has a warm air rising here. And you will also see it has divergence. We've seen it has divergence. It has divergence. A part of the air above diverges. A part of the air above diverges. But some part also sinks down. Some part also sinks down. Does it reach eye? No, it does not reach eye. If it would have reached eye, the low pressure would have not been sustained. So it does not reach eye, it reaches just a little above the eye. So what does a mature cyclone has? It has eye, it has eye, it has eye wall, it has rising air column, it has diverging air, and it also has some part of the sinking air, and it has a formation of a cumulus cloud. I'll repeat. What does a mature cyclone has? Eye wall, rising air column, diverging air column, a part of a sinking air towards the eye, but it does not reach the surface, and the whole part is a cumulonimbus cloud. So this is the mature fully grown tropical cyclone. Where and how it has formed in the ocean. Because of what? Because of the rising air and the diverging air, because of Coriolis force, because of the low vertical wind shear. This is what a tropical cyclone actually looks like. So what is happening in the mature stage? What is happening in the mature stage? If you look at in the mature stage, the rising air intensifies as the tropical cyclone and it spreads horizontally. When the air spreads, some portion migrates downwards and tries to subside in the eye. Okay, and this eye pressure zone is warm. The subsidence is not to the surface, it only reaches a depth of 1 to 3 kilometers. So how does a mature tropical cyclone actually looks like? This is how a mature tropical cyclone actually looks like. So this is your mature cyclone, and then what happens? Finally the cyclone ends. We know that the cyclone will be formed here. The cyclone is formed here, and it then starts moving under the influence of the trade winds. It starts moving under the influence of trade winds. As it is cut off from the energy source. As it is cut off from the ocean, if the cyclone reaches towards the coast, if the cyclone reaches towards the coast, it is cut off from the primary energy source, that is water, that is warm oceans, it dies. So what is the end of the cyclone? The end of the cyclone, that as soon as the source of the warm moist air is abruptly cut off, the tropical cyclone begins to weaken. On reaching the land, the moisture supply is cut off and the storm dissipates. The storm is getting dissipated. The place where tropical cyclone, okay, so this is the end of the tropical cyclone. You should know that the place where the tropical cyclone, crosses the coast, it is called as the landfall. Suppose this cyclone reaches the land here. When it reaches the land, it is called as what? It is called as the landfall of the tropical cyclone. It is called as the landfall of the tropical cyclone. So this is how the cyclone starts. Initiation stage in the oceans, fully mature tropical cyclone, and then when it reaches the land, the source is cut off. That way marks the end of the cyclone. That is, the landfall is marking the end of the cyclone. We've already seen the structure. Still we'll see the structure once more, that what is the structure of the tropical cyclone. As you can see, the structure of the tropical cyclone is here. This is from your NCERT. You have a eye here, you have the eye wall, you have the outflow, you have the subsiding warm air. This is the level of the tropopause. You have the rising area, and therefore you have rain bands. There's lot of clouds here. You'll see lot of clouds. This is rising air, therefore you have lot of clouds here. That is called as rain bands. So what is the structure of the tropical cyclone? The structure of the tropical cyclone is, first we are looking at what is the eye. What is eye? An eye is a roughly circular area at the center of the tropical cyclone. A circular area at the center of the tropical cyclone. Okay, it has mild winds. The winds are not very strong here. The winds do not rise very strongly here. The winds will rise strongly at the eye wall, not at the eye. Okay, there is little to no precipitation in the eye because the wind movement is not very fast. There is no precipitation or very little precipitation. The eye is a place which has lowest surface pressure. The surface pressure is very low. In the tropical cyclone, this area has the lowest surface pressure and it has the warmest temperature. It is very warm. It is warmer than the other parts of the tropical cyclone. There was a question that UPSC asked about the eye, that does the eye have a warm temperature than the other parts of the cyclone, or does it have low temperature and then the other parts of cyclone? You should know that it has warmer temperature, about 2 to 3 degrees Celsius warmer than the other parts of the tropical cyclone. So you have eye, the low pressure zone, vertical winds are not very strong, there is mild to less precipitation, and it has warmest temperature. The second one that we have is eye wall. It is also a circular ring that is surrounding the eye. It is the circular wind that surrounds the eye, and it has a strong spiraling ascent of air. Here the air movement is very strong. It will have high precipitation, it will have strong air, it will have vertical rising of the air. Here it is the area of the cyclone that has strongest surface wind. What is the velocity? The velocity of the wind can be as high as 250 km/h. Here, because the air is rising, what will you have? You will have lot of rainfall. You have torrential rainfall that is occurring here. So this is eye wall. Vertical movement is strong, very heavy rainfall, torrential rainfall, right? This is the eye wall. The next one that we have is spiral bands or the rain bands. Why spiral? Because the entire circulation is going on. So you will have lot of clouds. You will have trains of cumulus cloud, cumulonimbus clouds. You also have nimbus clouds. You have lot of clouds that are drifting to the outer region. Why are they called as spiral bands? The rain bands are called as spiral bands because they appear to spiral around the cyclone. They are moving, therefore they are called as spiral bands or the rain bands. Then where do you have tropical cyclone? We have the tropical cyclone in the warm oceans in the tropical latitude. So here you can look at the zones where you have the tropical cyclones. These are the zones where you have the tropical cyclones. You'll see that the tropical cyclone is seen. You'll see that the tropical cyclone is seen in the northern Atlantic. It is not present in the southern Atlantic. It is seen in the northern Atlantic. They are called as hurricanes along the coast of Mexico, along the coast of USA. You'll also see along the northern Pacific. Towards the China side and the Japanese side, they are called as typhoons in the South China Sea. You also have tropical cyclones in the Bay of Bengal region, in the Arabian Sea region. What are they called as? They are called as cyclones. You also have cyclones in the northern Australian region, also along the northern Australian region. So areas where they have, and what is the path they are following? They are moving from east to west. They are moving from east to west. They are moving from east to west. Under the influence of what? Under the influence of the trade winds, they are moving. So what are the breeding grounds for the tropical cyclone? The breeding grounds for the tropical cyclones are the Caribbean region, that is the northern Atlantic, they are called as hurricanes. The South China Sea, Philippines and eastern China, called as typhoons. You have Bay of Bengal, Arabian Sea. You also have somewhere along Madagascar and the African coast, and you also have along the northern Australia. So these are the places where you have the tropical cyclone, right? So this is from our side, a detailed discussion on the tropical cyclone. I hope you like the video. All of you, stay tuned. Thank you.